Alright, let's get started with Unit 3, Lesson 2, Classify Polygons and Angles in Polygons. Here we have two polygons. I'm stating that one is convex, the other is concave. I would like for you to pause the video and in your group discuss what you think makes one of them convex and what makes the other one concave. Okay, I know it's probably a little bit difficult to see, and this is probably your first introduction to these two words. Well, a convex polygon is a polygon that has none of its sides on the interior of the polygon. So here, if you can see, this would be considered the interior of the polygon. None of its sides actually break that barrier. And a concave polygon is going to have its sides in the interior of it. So you can see right here, it goes inside the polygon. So convex, no sides on the inside. Concave, it's got sides on the inside. And let's just formalize these two definitions. So convex is a polygon is convex if no side of the polygon passes through the interior of the polygon. And our concave is a very simple definition, a polygon that's not convex. So if it's convex, no side on the inside, concave means it's not convex. Okay, and now we have three polygons. We have a quadrilateral, we have a triangle, and we have a pentagon. And I'm telling you the quadrilateral is equilateral, the triangle is equiangular, and that pentagon is regular. I'd like for you to pause the video and discuss with your group what makes the quadrilateral equilateral, what makes the triangle equiangular, and what makes that pentagon regular. Okay, let's start over here with the quadrilateral. Equilateral. Well, let's break down the word. Equa. We've run into that before. Normally that means something is equal. Lateral. If you think about lateral, you kind of think about moving side to side. So that would be side. Equal sides. Equilateral. You can see also in the picture that it's denoted that each of these sides are congruent. So that tells us that they're also equal, because congruent means that their measures are equal. So if it be equilateral, all sides are congruent. So all sides are congruent. Equiangular. Well, again, we have that equa for equal, and then we have angular, and that looks like angle. So we have equal angle. But you can see I also again denoted all of these angles are congruent, which means they also have measures that are equal. So an equiangular means that all angles are congruent. And finally, regular. Now there's nothing really in the words here for us to break down. But if you look, the picture looks kind of like a combination of the first two. Looks like all its sides are congruent. Looks like all its angles are congruent. And that's what makes it regular. A regular polygon means that it is both equilateral and equiangular. One last time, equilateral, all sides are congruent. Equiangular, all angles are congruent. Regular, it's both equilateral and equiangular. Okay, on this slide we have I give you an introduction to a few of the polygons we'll be working with. There's a triangle, a quadrilateral, a pentagon, a hexagon, a heptagon, and an octagon. And their names come from their sides. Tri meaning 3, quad 4, penta 5, hexa 6, hepta 7, and octa 8. And then in between the figure and the name, there are these angle measures. That is the measure of all of the interior angles. If you were to add up all the interior angles, that's the number you would get. Now I want you to pause the video and in your group, try to figure out where does this number come from. There's a formula, and I want you to take a look at the sides, take a look at what you think the angles might be to figure it out. Okay, so let's discuss that formula. I know it's probably a little difficult to come up with that. So, the formula for the interior angles is n minus 2 times 180. Now I bet you got this 180 in there, which is good. But this n minus 2 part's the hard to see. And you're probably wondering what's n? Well, n equals the number of sides. So let's just look at the triangle. Triangle has 3 sides. So we do 3 minus 1, 3 minus 2 times 180. 3 minus 2 is 1. 1 times 180 is 180. So that's where we get that 180 degrees, and that's our formula, that n minus 2 times 180, with n equal to the number of sides. Okay, last thing we're going to talk about is the exterior angles. The exterior angles are on the outside, and they're created by just extending a line, by just extending a side to form another line on the outside. And this is an exterior angle, this is an exterior angle, and this is an exterior angle. Now there's no formula really for these exterior angles. All you need to know is that what you need to know about the exterior angles is that as long as each exterior angle is extended in the same way, they all add up to 360 degrees. So all the exterior angles will add up to 360.